Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, and of course, if you have younger brothers and sisters who would want to take up engineering, then there are playlists here which are important in their preparations to engineering life. And if you have also relatives who are planning to take up engineering, then you may share my videos to them. So here is Engineers in Progress 2.1. Problem 1, use a calculator to compute the power to 4 significant digits. Express the result in scientific notation. So here are the problems, and you also have your parts E and F. So if you have a calculator, then you have to type 35.7 raised to 3, and the result is 45,499.3 to 6 significant figures. Expressing this in scientific notation to 4 significant digits, then we have 4.550, not 4.549, because the next is 9. So this is written in scientific notation to 4 significant digits. 4.550 times 10 to the 1, 2, 3, 4. So 4.550 times 10 to the 4. Then for the next problem, use your calculator. 3.78 quantity raised to negative 5, and it is automatic. 1.296 times 10 to the negative 3. So there's no need to transform it into scientific notation and expressing it to 4 significant figures. Next is 0.2615 to the 8. So using your calculator, it will automatically give us these results also, but our job is to just round off the value to 4 significant digits. So 2.24 significant digits. So 2.187 times 10 to the negative 5, and this is expressed to 4 significant digits and in scientific notation. Then next, with your calculator there, type quantity 0.4034 to the negative 3, and it is 15.23. Since this is not yet in scientific notation, we move the decimal to the left, and moving it to the left will have positive exponents, so 1 only, so times 10 to the 1. It is 1.523 times 10 to the 1 in scientific notation and to 4 significant digits. Then for your part, quantity 4.261 to the 25, show that it is equal to 5.467 times 10 to the 15. And this one, quantity 32.45 to the negative 10, show that it is 7.724 times 10 to the negative 16. So that's it for this first part, and I hope that you find it simple and easy. And you will have this especially for those who are planning to take up engineering. In your experience with calculations, definitely you will express answers to scientific notations and to 4 significant figures, or maybe 3 significant figures or digits. Problem 2, write the number in scientific notation. So 172,000 in scientific notation and to 3 significant digits. Next is 0.00615 to 3 significant. Of course, there are 3 significant figures here. So we also round this off to and write this in scientific notation to 3 significant digits also. 172,000, but this time to 4 significant digits. Then 0.00008022. There are 4 significant figures, so therefore we we transform this to scientific notation and with 4 significant digits. So the first one is 1.72 times 10 to the 5. So beginning here, we have 1, 2, 3, 4, 5. So moving the decimal to the left means the power of 10 is positive. So 5 times 10 to the 5. And to 3 significant digits, so 1.72. 1, 7, and 2 are the significant digits. Then this will be your part. The next one is moving the decimal to the right. We'll have power of 10 negative raised to a negative power. So 1, 2, 3. So this is 6.15 to 3 significant figures times 10 to the negative 3. So we move the decimal to 3. So this is 6.15 times 10 to the negative 3. Then this 172,000 to 4 significant digits, it is still 1.72, but this is to 3 significant digits, making this 4 significant digits, so we add the next digit, which is 0. So this is written 1.720 times 10 to the 5 and to 4 significant digits. So the 0 in the last place of the decimal is significant, or else we do not put it there. So there will be 3 significant figures only if we do not put the next digit, which is 0, and this is significant. This is 4 significant figures. Zeros between significant figures are significant. So putting this in scientific notation, we have 1, 2, 3, 4, 5, 6. So this is 8.022 times 10 to the negative 6, rounding off that value to 4 significant figures and transforming it to scientific notation. This is your part. Show that this is 3.960 times 10 to the negative 2. And this one is moving the decimal to 2. So 4.250. So meaning to say this 0 here is significant. So there are 4 significant figures. So to 4 significant figures, this is written 4.250 times 10 to the positive 2. Then problem 3, use scientific notation and a calculator to perform the indicated operations. Assume 4 significant digits in the final value. Of course, if you use your calculator and write 320,000 square, I don't think the calculator can display that value. So that's why we have to use it by, before multiplying, we express first the numbers to scientific notation. So this is your part here. So this is written as 1 to 4.70 times 10 to the negative 2 times 1, 2, 3, 4, 5. 3.200 times 10 to the 5, then quantity square. So 4.70 times 10 to the negative 2 times 3.20 times 10 to the 5 quantity square. So the power of 10 here would be 5 times 2, 10 to the 10, while this one is still 10 to the negative 2, but 3.2 is squared. Therefore, using your calculator, 4.70 times 3.20 square, and the power would be times 10 to the 8. 10 minus 2 is 8. 5 times 2 is 10. Then plus negative 2 is 8. So all you have to do in your calculator, type 4.70, then times 3.20 square. It will be 48.13 times 10 to the 8. But this is not the proper way of expressing the value in scientific notation. So we have to move this decimal ones to the left. So this is 4.813 times 10 to the 1, then times 10 to the 8. So it becomes 4.813 to 4 significant figures times 10 to the 9. So the final expression is 4.813 times 10 to the 9. Then 3b, this is 1.12345. 1.800 times 10 to the 5, then quantity cube. While this one is 1, 2, 3, 4, 5, 4.50 times 10 to the negative 5 quantity square, all over 6.23 times 10 to the 5 quantity square. So this is 1.8 cube times 10 to the 15, then times 4.5 square times 10 to the negative 10, all over 6.230 square times 10 to the 10. So 6.23 square times 10 to the 10. So the role of the calculator would be to evaluate 1.8 cube or 1.800 cube times 4.500 square, then all over 6.2230 square. Then it will be times 10 to the 15 minus 10 is 5, then minus 10 is negative 5. So it is times 10 to the negative 5, and we put the value of 1.8 cubed times 4.5 square over 6.23 square from the calculator. The result is 3.043, and the power of 5, the power of 10 is negative 5. 15 minus 10 is 5, minus 10 is negative 5. Since this is already the proper way of or proper position of the decimal, so that's the final answer, 3.043 times 10 to the negative 5. Part C, this is 3, 6, 8. So 2.56 times 10 to the 8 quantity square times 7.12 times 10 to the negative 2 quantity cube, all over 3.48 times 10 to the negative 4 quantity cube, then 5.100 times 10 to the 3 quantity to the fourth. So this is 2.56 square, 10 to the 16 times 10 to the 16, 7.12 cubed times 10 to the negative 6, all over 3.48 cubed times 10 to the negative 12 times 5.100 to the fourth times 10 to the 12. So the role of the calculator is to perform the product 2.56 square times 7.120 cube all over 3.48 cube times 5.1 to the fourth, and it will be times 10 to the 16 minus 6 is 10, then negative 12 plus 12 is 0. So whatever is the result from the calculator, 2.56 square times 7.12 cube all over 3.48 cube all over 5.1 to the fourth, then it will be times 10 to the 10. 16 minus 6 is 10, and in the denominator it is negative 12 plus 12 is 0. So it's just times 10 to the 10. From the calculator, it is 0.08297 times 10 to the 10. And since this is not the proper position of the decimal, so this is supposedly 1 to 8.297 to 4 significant digits times 10 to the negative 2. So negative 2 plus 10 is positive 8. Therefore, it is the final answer is 8.297 times 10 to the 8. So that's it for this exercise, Engineers in Progress 2.1. And I hope that the students who would want to become engineers in the future will have this experience in their preparations.